Hi guys, welcome to this hands-on tutorial on SAP S/4HANA and EWM system connection settings, the first step in building a seamless logistics integration. In this video, we'll walk through the real-time configuration required to connect your ERP system with Extended Warehouse Management (EWM) using actual SAP screens, not just theory or slides. Whether you're working with embedded EWM or a decentralized setup, understanding how to define logical systems, RFC destinations, and client assignments is essential. These settings form the backbone of your integration and ensure that data flows smoothly between S/4HANA and EWM. This tutorial is ideal for SAP consultants, logistics professionals, and technical architects who want to master the system connection layer with confidence. So stay with me as we configure each step inside the SAP system, clearly, practically, and with purpose. And if you're following the full series, this is your foundation. Let's get started. In order to understand easily, we have divided S/4HANA EWM system connection basic settings in 3 stages. Stage 1 is general settings for the system landscape and the QRFC communication where logical systems, RFC destinations, QOUT and QIN Scheduler etc. are configured. Stage 2 is settings for master data integration. Here business system group, assign logical system and queue type etc. are configured. Stage 3 is settings for application integration. Here own business system, assign BP to plant and RFC queue control etc. are configured. Let us go to stage 1. If you're working on SAP S/4HANA and EWM integration, understanding logical systems is absolutely essential. They act as unique identifiers for each client or system within your SAP landscape, enabling secure and structured communication between ERP and EWM. Without them, your system won't know where to send or receive data, and integration simply won't work. Take the help from BASIS colleagues to create the logical system for S/4HANA as well as EWM. Check their presence through T-code BD54 or following the path as shown. Both these logical systems should be available as RFC destination type. 3 means ABAP connection. Check this through T-code SM59 or following the path as shown. Now we will assign logical systems to client. Please follow the path shown and check that S/4HANA logical system is assigned to the client. In case of any issue, take the help from BASIS colleagues. If you are configuring S4 and EWM connection for decentralized EWM on S/4HANA, then please follow the path shown and check that EWM logical system is assigned to the client. In case of any issue, take the help from BASIS colleagues. On the screen, You see the S/4HANA logical system here because this setup is for embedded EWM. If it were decentralized EWM system, you would see the EWM logical system maintained instead. Next configuration is BD97. Assign RFC destination for synchronous method calls. Transaction BD97 in SAP is used to assign RFC destinations for synchronous method calls in ALE, Application Link Enabling. This step ensures that when a synchronous method is executed, the system knows which RFC destination to use for communication with the target system. Proper assignment of RFC destinations is important to enable real-time data exchange and avoid errors during method execution. In the context of S/4HANA and EWM integration, maintaining the correct RFC destination in BD97 ensures smooth and reliable communication between the systems. Go to Transaction BD97 or the path shown on the screen and select the logical system for which you want to assign the RFC destination. Enter the RFC destination that points to the corresponding target system. For embedded EWM, use S/4HANA logical system. For decentralized EWM, use EWM logical system, and in the corresponding EWM system use S/4HANA logical system. The data transfer via APO Core Interface (CIF) occurs using queued remote function calls (QRFC). Outbound QRFCs, outbound queues, are processed by the QOUT Scheduler. The QOUT Scheduler is called using transaction SMQS. The destinations to which the outbound QRFCs are to be sent are registered in the QOUT Scheduler. Go to Transaction SMQS, Scheduler for outbound queues. Check whether the destination is already registered. If not, create a new entry. Destination, RFC destination created in SM59. Maximum connections, usually set to 1 to 5 depending on system load. Activation type, select registered. Save the entry. Use registration button to activate it. Always check that the outbound scheduler is active, otherwise outbound queues will remain stuck. Always schedule background jobs to reprocess stuck queues using program resqueuex. In the next configuration, we will configure QIN inbound queue. The QIN inbound queue is used in SAP to manage and control inbound messages coming from another logical system through TRFC QRFC. It ensures that messages are processed sequentially, reliably, and without duplication. Correct configuration of QIN is critical to guarantee smooth inbound communication. Go to Transaction SMQR, Scheduler for inbound queues. Check if the RFC destination is already listed. If not, create a new entry. Queue name, usually generic, like asterisk, to allow all queues, or restrict to specific queues shown on the screen. QOUT Scheduler, define processing priority. Maximum processes, set based on system capacity, e.g., 5. Activation type, registered. Save the entry. Ensure the inbound scheduler is active, otherwise messages will remain stuck in inbound queues. Go to SMQR and create entries CF asterisk, DLV asterisk, DLW asterisk, EWM asterisk, PR asterisk, QI asterisk, QM asterisk, TU asterisk, UL asterisk, WM asterisk, X asterisk 1 by 1 as explained. configure Stage 2, Settings for Master Data Integration. We will maintain Business System Group, assign Logical System and Queue Type in this configuration. Business System Group. In this IMG activity, we determine the assignment to a Business System Group of S/4HANA and EWM system that are to be connected. By doing this, we create areas with the same naming conventions. These guarantee that the same names are used for master data and also their synchronization in distributed system landscapes. Follow the path as shown on the screen and assign the Business System Group. In embedded EWM system, maintaining only one system under Business System Group is sufficient, which should be S/4HANA. We will see this in the next step. For decentralized EWM, we will maintain different Business System Group in S/4HANA and in EWM system. For example, BSG in S/4HANA system and BSG1 in EWM system. In the next configuration, we will assign Logical System and Queue Type to the Business System Group. Here we assign a Logical System to a Business System Group, BSG. Also we assign a Queue Type, Inbound Queue or Outbound Queue, to the BSG. To enable error-free communication, every source system must be assigned to a BSG. A BSG can consist of one or more source systems. If we are transferring a large amount of data to the ERP system and you want to ensure an even load on the ERP system, choose inbound queues. In this case, we must make the necessary settings for the QIN queues that the ERP system is to process automatically must be registered in the QIN Scheduler. Follow the path as shown on the screen and assign the Logical System and Queue Type to the Business System Group. In embedded EWM system, assign the S/4HANA Logical System to the Business System Group. For decentralized EWM, in S/4HANA assign the S/4HANA Logical System to the Business System Group. In EWM system, assign both S/4HANA and EWM Logical System to the Business System Group. Now we have come to Stage 3 where we will configure settings for application integration. The following configuration is done here: define Own Business System, define Business System, assign Business Partner to Plant and Control for RFC queues. Define Own Business System. System defined here would be the system in which EWM is located. The system must be the same as the system key defined in the System Landscape Directory, SLD. Follow the path on the screen and enter the system key for SAP EWM Logical System as a business system. In an embedded EWM setup, the EWM system runs within the same instance as S/4HANA. That's why we assign our own system, for example, S4H_800. In a decentralized EWM setup, the EWM system operates as a separate standalone system, so here we enter the key corresponding to that external EWM system. Define Business System. In this step, we link logical systems to business systems. When deliveries are sent from the ERP system to EWM, they only carry the logical system information. EWM then uses this configuration to map the logical system to the correct business system and stores it in the delivery. Similarly, when sending confirmations back to ERP, EWM maps the business system to its logical system and sends the message to the right ERP system. Each business system must be assigned to only one logical system, ensuring a unique and consistent mapping. This setup allows EWM to communicate correctly with the ERP system. Example: if the ERP system has a logical system called ERP-CLNT100, you can map it to a business system named BS_ERP100. When ERP sends a delivery, EWM recognizes ERP-CLNT 100 and automatically maps it to BS_ERP 100. In the same way, when EWM sends back a confirmation, it uses this mapping to ensure the message reaches the correct ERP system. Follow the path and specify a business system for each logical system that will be connected to EWM and assign the relevant logical system. In embedded EWM, it will be logical system and business system for S/4HANA. In decentralized EWM, it will be again S/4HANA system. We must assign a logical system to only one business system. Assign business partner to plant. Here we maintain a link between a party entitled to dispose, disposal party, and a plant. This links the plant to a business partner that is only used to manage stock in the warehouse. This business partner is different from A, the business partner in the vendor role or the customer role that is assigned to a plant and used as ship to party or ship from party in the stock transport order processes. B, the business partner used as the default ship to party of the warehouse in direct outbound delivery orders created through MIGO. For embedded EWM in SAP S/4HANA, this assignment is optional. In case of embedded EWM, system uses the business partner in the vendor role that is assigned to the plant as the disposal party. For decentralized EWM, this assignment of a disposal party to a plant is mandatory. In this customizing activity, we define the control of the RFC queues for SAP ERP. Please follow the path as shown in the next screen and do the configuration as shown. Use the business system corresponding to the S/4HANA system. That wraps up our first deep dive into SAP S/4HANA and EWM integration, where we covered the essential system connection settings using real-time SAP screens. From defining logical systems to configuring RFC destinations and client assignments, you've now seen how the foundation of this integration is built, not just in theory, but inside the actual system. This video is part of a structured 3-part series, following our introductory overview. If you haven't watched that yet, I recommend starting there to get the full roadmap. Up next is Step 2, where we'll configure the ERP side integration settings that enable smooth data exchange with EWM. That video is available separately, and you'll find the link in the description below, along with the full playlist for easy access. Thanks for watching and learning with SAPLogisticsExpert.com. If you found this helpful, consider subscribing and sharing it with fellow SAP professionals. Let's continue building this integration, step by step, screen by screen.